Good morning everyone. I am Mrs. Kanimuli, Assistant Professor Biomedical Engineering, SSCET. Today I am going to explain about working principle of silicon control rectifier. A silicon control rectifier is a 4-layer semiconductor device. It used to control high power in electrical circuits and it belongs to the thyristor family and work as a controlled switch. The silicon control rectifier, shortly called as SCR. SCR is a power electronic device. It is mainly used to control high voltage and high current. SCR is a 4-layer semiconductor device. It has arranged as PN layers. It works as a switch. When we give a signal, it will turn on. Without signal, it says off condition. The SCR has 3 terminals. One is anode, another one is cathode, then gate terminal. The gate terminal is used to turn on the SCR and it consists of 3 junctions. The junction J1, J2 and J3. The constructions of SCR. The SCR is a 4-layer semiconductor PN. The junction is J1, J2, J3 and the terminal is anode, cathode and gate. The PN, this area is this area, and then area is junction 1, this area is junction 2 and this area is junction 3. Next, 2 transistor analogy. The 2 transistor analogy means it is a method of explaining the working of an SCR by representing it as 2 interconnected transistors. Then one is PNP, another one is NPN. The PNP transistor denoted by T1 and NPN transistor denoted by T2. An SCR has 4 layers PN. The structure can be divided into one PNP transistor T1, then one NPN transistor T2. These 2 transistors are connected so that collector of T1, this terminal is collector, this terminal is emitter, this one is base. Next, this T2 transistor, this terminal is base and this terminal is collector, and finally this one is emitter terminal. So the collector of T1 transistor is connected to base of the T2 transistor. The collector of T1 transistor is connected to the base of the T2 transistor, and collector of the T2 transistor is connected to the base of T1 transistor. Because of this connection, they provide positive feedback. Then, how the used to in transistor, two-way transistor. Why used in two-way transistor? The SCR working in 3 type of mode. First one is forward blocking mode, second one forward conduction mode, then finally reverse blocking mode. First, forward blocking mode or forward bias without gate signal. The anode, when a positive voltage is applied to the anode of the SCR with respect to the cathode and with 0 gate current, the junction J2 will be reverse bias and therefore the device will not conduct. This is the forward blocking mode of SCR. SCR is the 4 layers PN and PN. First, anode, this terminal is anode. First, we apply the positive supply to the anode terminal with respect to the cathode. But the gate terminal, no gate signal is given. So totally SCR behaves like off switch. It behaves like an open switch. Next one, forward conduction mode. Forward conduction mode or forward bias with gate signal. Forward bias with gate signal. Anode is positive and small positive pulse given to the gate terminal. So SCR turn on. So SCR is turn on. Large current. So large current flow from anode to cathode. From anode to cathode. We note important 2 points. Then finally, reverse blocking mode. Reverse blocking mode, when the cathode of ACR is made positive with respect to the anode, the junction J1 and J3 will be reverse bias and therefore the device will not conduct. Okay, this is the reverse blocking mode of ACR. When ACR behave like reverse bias diode, only small leakage current flow. Okay, we note two important points. One is after turning on, SCR will not turn off automatically. It turn off only when current becomes zero. When current becomes zero. So operating modes, okay, overall see the SCR operating modes, forward conduction mode, and SCR will go into forward conduction mode in two ways. One is without gate current, the anode voltage is increased beyond a certain level called breakover voltage VB0. And then second one is a gate current is applied so that the SCR starts conducting. Once the SCR starts conducting, no gate current is needed to maintain the anode current. So next, SCR characteristics, VI characteristics. The important terms for the graph, first one is breakover voltage. The breakover voltage is the minimum forward voltage at which an SCR turn on automatically without applying and gate signal. The breakover voltage is usually high. Normally, we do not use breakover to turn on SCR, and we use gates pulse because it need lower voltage. It is the point where the forward blocking region ends. Then the breakover voltage marked as VB0 in the graph. So next important point, holding current. I sufficient H. It is the minimum current that must flow through an SCR to keep it in the on state. It measured after removing the gate signal. SCR turn off only when current less than holding current. So the holding current is very high. So what is latching current? The latching current is the minimum current that must flow through an SCR immediately after it is turned on to keep it on when the gate signal is removed. So latching current is measured just after triggering. Usually latching current greater than holding current. After latching, SCR remain on even if gate signal is removed. The latching current it represents as I, located in the forward conduction region. Then advantage of SCR, handle high voltage and current, simple triggering, and then reliable. And disadvantage cannot be turned off by gate, only work in one direction. It's a real-time application. So first one, dimmer, light dimmers. The light dimmers, it control brightness of lamp used in home lighting, theaters, stage lighting. The next one, motor control speed. The motor control speed used in DC motor drives. It controls speed by adjusting voltage used in electronic trains, elevators, conveyor belt, then industrial machines. Then third one, battery charges. It used in control rectifier circuit and regulate charging current. Used in UPS systems, inverter batteries, automobile battery chargers. And then inverters. Inverters means inverters is it used to convert DC to AC, used in UPS system, solar power system. Then finally regulators. And rectifiers, control rectifiers. The rectifiers is AC to DC converters used in DC power supplies, electroplating, then welding machines. Okay, thank you students.